Hi, welcome all to online classes. I'm Mukesh Bhardwaj, going to teach a topic, vector analysis and coordinate system. For the subject electromagnetic field theory, we take a fourth semester in the engineering, electronics and communication engineering. So, vector analysis and coordinate system are the basic fundamentals need to further study the electromagnetic field theory, and they are the helping tools for the analysis of electromagnetic field theory. So, vector analysis and coordinate system, the following contents need to be covered under this topic: vector analysis, vector arithmetic addition, subtraction, multiplication, division, unit vector, uh, dot product, cross product, coordinate system. The following objectives: to understand basic of the vector, to learn the vector arithmetic, to learn the dot product and cross product of vector quantities, and further the following outcomes: students are well equipped to handle important practical problems in vector analysis. Student will learn arithmetic operation of vector quantities. They are able to solve dot product and cross product of vectors. The reference book is Ano Sadiqiu. Now, the vector analysis. The quantities that deal in electromagnetic theory may be either scalar or vector, maybe scalars or are vectors. Scalars are quantities characterized by the magnitude only and algebraic sum. Magnitude only and algebraic sign. The quantity that has direction as well as magnitude is called a vector. Both scalar and vector quantities are function of time and position. A field is a function that specifies a particular quantity everywhere in a region. Depending upon the nature of the quantity under consideration, the field may be a vector or scalar field. Example of a scalar field is electric potential in a region where electric or magnetic fields at any point is the example of vector field. A vector can be written as a small a into a, where a is equals to magnitude a is the magnitude and a is equals to a by unit vector. A unit vector is equals to a vector upon magnitude a is the unit vector which has unit magnitude and same direction as that of a. A scalar has magnitude, mass, time, temperature, charge. They are known as the scalar quantities. A vector has magnitudes, its length and direction. Example: velocity, force, momentum, field strength. Vector addition: addition of two vectors results in another vector. Which denote as C. Therefore, a plus b is equals to C. The magnitude and direction of C is determined by the hand to tail rule, or left hand or right hand Fleming's left hand rule and right hand rule. It has many applications in physics. Some important properties of vector addition. Vector addition is commutative. A plus B equals to B plus A. Vector addition is associative. X plus Z equals to X plus Y plus Z equals to K. For these two properties, the addition of several vectors can be executed in any order. Addition of two vectors A plus B. This is the presentation in figure where we are just going to find out the addition of two vectors A and B. Vector subtraction, the addition of a negative vector as a subtraction. The vector subtraction is similarly carried out. D is equals to A minus B or A plus minus B. Multiplication of vector. Consider a scalar vector A and A vector quantity B. The multiplication of these two values as AB equals to C. The product of a scalar and vector is a vector. The resulting vector C has a magnitude that is equal to A times the magnitude of B. The direction of vector C is exactly that of B. Some important properties of vector multiplication. Multiplying a vector by a scalar changes the magnitude of vector, but not its direction. The scalar vector multiplication is distributive. AB plus BA equals to A plus B into B. Also distributive as AB plus AC is equals to AB plus C. Scalar vector multiplication is a commutative. AB equals to BA. Some important properties of vector multiplication. Multiplication of a vector by a negative scalar is interpreted as minus AB equals to A minus B. Division of a vector by scalar is the same as multiplying the vector by the inverse of the scalar. B by A is equals to 1 by A B. Divide unit vector. Divide vector A by its magnitude. A scalar value, a new vector is formed, which will denote as a vector or a unit vector. The vector unit vector is given as a vector upon mod of A. The vector, the unit vector has the same direction as vector A. The unit vector A has magnitude equal to one such vector is known as unit vector. A unit vector is essential at description of direction only, as its magnitude is always unit value that is equal to 1. Therefore, magnitude is a scalar value that describes the magnitude of vector A. A unit vector is a vector that describes the direction of A. The dot product of two vectors A and B is denoted as A dot B, or A dot B equals to mod A mod B cos theta, angle between A and B. Angle theta AB is the angle formed between the vectors A and B, and theta AB lies between 0 to pi. Important note, the dot product is an operation involving two vectors, but the result is scalar. The dot product A dot B is equals to C. The dot product is also called the scalar product of two vectors. Note also that the dot product is commutative, that is A dot B equals to B dot A. The dot product of a vector with itself is equal to the magnitude of the vector squared. A dot A is equals to magnitude A into magnitude A cos theta is equals to magnitude of A square. If A dot B is equals to 0 and A is not equals to 0 and B is not equals to 0, then it must be true that the theta AB, that is the angle between these two vectors, are 90 degree. If A dot B is equals to mod A mod B, then it must be true that theta AB equals to 0 degree. If the A dot B is equals to minus AB, then it must be true that theta equals to 180 degree. The dot product is distributive with addition such that AB plus C is equals to AB plus AC. The cross product of two vectors A and B is denoted as A cross B. A cross B is equals to AN mod A mod B sin theta AB. Just as with the dot product, the angle theta AB is the angle between the two vectors A and B. The unit vector AN is orthogonal to both A and B. That is, AN dot A is equals to 0 and AN dot B is equals to 0. Important note, the cross product is an operation involving two vectors and the result is also a vector. Example, A cross B equals to C. The magnitude of vector A cross B is therefore A cross B is equals to mod A mod B sin theta AB. While the direction of vector A cross B is described by a unit vector AN. The cross product, if theta AB is equals to 90, that is orthogonal, then A cross B is equals to A unit vector into mod A mod B sin 90 is equals to A unit vector mod A mod B. If theta AB is equals to 0, that is parallel, then A cross B is equals to 0. Note that A cross B is equals to 0 also if theta AB is equals to 180 degree. The cross product is not commutative. In other words, A cross B is not equal to B cross A. While evaluating the cross product of two vectors, the order is important. A cross B is not equal to minus B cross A. The negative of the cross product is minus A cross B is equals to A cross B minus B. The cross product is also not associative. A cross B cross C is not equal to A cross B cross C. But the cross product is distributive in that A cross B plus C is equals to A cross B plus A cross C. The triple product. The triple product is not a new operation as it is simply a combination of the dot and cross product. For example, the triple product of vectors A, B and C is denoted as A dot B cross C. So A dot B cross C. So vector dot vector scalar triple product A dot B cross C is equal to B dot C cross A is equals to C dot A cross B, that is cyclic. This is the determinant form of three vectors multiplication. Now coordinate system. The dimension of space comes from nature. The measurement of space comes from us. The laws of electromagnetic are independent of a particular coordinate system. However, application of the laws to the solution of a particular problem imposes the need to use a suitable coordinate system. It is the shape of boundaries that determine the most suitable coordinate system to use in its solution. To represent points in space, need a coordinate system. The coordinate system may be orthogonal or non-orthogonal. Coordinate systems can also be right-handed or left-handed. The coordinate system discussed are three-dimensional coordinate system. The coordinate systems are defined by a set of planes and or surfaces. A coordinate system defines a set of three reference directions at each and every point in the space. The origin of the coordinate system is the reference point relative to which we locate every other point in space. A position vector a position vector a position vector defines the position of a point in a space relative to the origin. The reference directions the three reference directions are referred to as coordinate directions. Unit vectors along the coordinate directions are called base vectors. In any three-dimensional coordinate system, an arbitrary vector can be expressed in terms of superposition of the three base vectors. Different coordinate systems are different ways to measure space. Three most commonly used orthogonal coordinate system is Cartesian coordinate system, cylindrical coordinate system, spherical polar coordinate system. Rectangular Cartesian coordinate system. The rectangular Cartesian coordinate system is described by three planes which are mutually perpendicular to each other. The three planes intersect at point O, which is called the origin of the coordinate system. There are three coordinate axes which are usually denoted by x, y, z. Values of x, y, z are measured from the origin. The three planes are x equals to constant plane, that is yz plane, y equals to constant plane, that is xz plane, z equals to constant plane, that is xy plane. These are the some pictorial representation of x, y, z plane in which some Cartesian coordinates are shown with respect to the origin. Rectangular Cartesian coordination system, x equals to constant parallel to a yz plane, y constant parallel to xz plane, z constant parallel to xy plane. So the value lies from minus infinity to plus infinity for all the x, y, z values. A point in rectangular coordinate system is defined by x, y, z. The limits for the coordinates are minus infinity to infinity, minus infinity to infinity for y, and the same minus infinity to infinity for z. The unit or base vectors are ax, ay, az. The following relationship hold for the dot and cross product of the unit vectors. Ax into ay is equals to az, ay into az equals to ax, az into ax equals to ay, ax dot ay equals to 0, ay dot az equals to 0, az dot ax equals to 0. The differential length element is given by dl equals to dxa x plus dy ay plus dz az. So dx, dy, dz are the differential length in x, y and z direction respectively. And the magnitude of dl is equals to given by root dx का whole square plus dy का whole square plus dz का whole square. The differential area elements are ds rec is equals to ds san, where ds is equals to differential surface area of the element. Unit vector or vector an is equals to unit vector normal to the surface ds. Dsx is differential vector surface area normal to x direction equals to dy by dz, dy dz ax. dsy is equals to differential vector surface area normal to y direction dx dz ay vector. dsz is equals to differential vector surface area normal to z direction dx dy az vector. So these are the differential element, the dx vector and dsy vector, dsz vector. So the volume is given as dx dy by dz. Note that the coordinate value in the Cartesian system effectively represent the distance from a plane intersecting the origin. For example, x equals to 3 means that the point is 3 units from the yz plane. That is, the x is equals to 0 plane. Likewise, the y coordinate provides the distance from the xz, y equals to 0 or xz plane, and the z coordinate provides the distance from the xy, that is z equals to 0 plane. Likewise, the y coordinate provides the distance from the x minus z, y equals to 0 plane, and the z coordinate provide the distance from the x minus y, z equals to 0 plane. Once all three distances are specified, the position of a point is uniquely identified. Now some solved examples. Question number 1, that is given as vector A equals to ax plus 2y plus 3z and b equals to minus 2ax plus 3ay. Determine the angle between the vectors A and B. Find the unit vector which is perpendicular to both A and B. So we know the solution that for two given vectors A and B, A dot B is equals to given by AB cos theta. So mod of A is equals to square root 14, mod of B is square root 15 or 5. So square root 15 into square root 5 cos theta is equals to 1, or theta equals to cos inverse 1 by square root of 1 by 70. Vector transformation followed by coordinate point substitution and vice versa, both given the same result. Choose the best answer. Possible when the vector is constant, possible when the vector is variable, possible in all the cases, not possible. So choose the right answer. Which of the following criteria is used to choose a coordinate system? Distance, intensity, magnitude, geometry. Choose the right answer or appropriate answer among the four choices. Which of the following criteria is used to choose the coordinate system? Appropriate answer is geometry. The Cartesian coordinate can be related to the cylindrical coordinates and spherical coordinates. Statement is true or false. So just the statement is 100% true. The angular separation between the vectors A 4i plus 3j 5k and B I minus 2j plus 2k is angular separation means the angle between the two vectors. So A dot B is equals to mod A mod B cos theta. So cos theta is equals to A dot B upon mod A mod B. So just do the dot product and divide by the mods, and theta equals to cos inverse. The final results come out and choose the appropriate answer. The scalar factor of Cartesian system is unity. State true or false. So choose the appropriate answer. A charge is placed in a square container. The position of the charge with respect to the origin can be found by choose the appropriate answer: spherical system, circular system, Cartesian system, space coordinate system. So the right answer is space coordinate system. The volume of a parallel pipe in a Cartesian is, choose the appropriate answer. The Cartesian system is also called as space coordinate system. A vector is said to be solenoidal when it is divergence is zero, divergence is unity, curl is zero, curl is unity. So the vector is said to be solenoidal. Choose the appropriate answer. When a vector is irrotational, which condition holds good? Stokes theorem gives non-zero value. Stokes theorem gives zero value. Divergence theorem is invalid. Divergence theorem is valid. So choose the appropriate answer. Two forces whose magnitudes are in the ratio of 3 to 5 given a resultant of 35 Newton. If the angle of inclination is 60 degree, calculate the magnitude of each force. So P equals to 3x and Q equals to 5r equals to 35 and theta is equals to 120 degree. R equals to s square root of p square plus r square plus 2pq cos theta. So 35 equals to 7x, or x equals to 35 by 7, or x equals to 5. So P is equals to 15 Newton and Q is equals to 25 Newton. Walking of a man is an example of, while walking, a person presses the ground with his feet slightly slanted in the backward direction. The ground exerts upon him an equal and opposite reaction. Its horizontal component enables the person to move forward, while the vertical component balances this weight. Which of the following is not a vector quantity? Velocity is a vector quantity. Displacement is a vector quantity. Speed and acceleration. So acceleration is a vector quantity, but speed is not a vector quantity. Which of the following has a magnitude 1? Free vector, null vector, unit vector, position vector. So choose the appropriate answer. The answer is unit vector. A vector whose initial position is at origin is a free vector, position vector, unit vector, or deemed none. So a vector whose initial position at origin is known as position vector. Which of the following holds true for a vector quantity? It has only magnitude. It has only direction. A vector has both direction and magnitude. A vector can never be negative. So a vector has both direction and magnitude holds true for a vector quantity. A scalar quantity has only magnitude and no direction. The statement is true. Which of the following is the correct symbol for denoting a given vector? C. Which of the given quantity is vector? Speed, time, weight, volume. So the speed is the having a vector quality. Which of the following is not a vector quantity? Speed, density, force, velocity. So speed is not a vector quantity. Which of the following below given is a vector quantity? 8 kg, 4 seconds, 6 Newton, 90 centimeter. 6 Newton is a vector quantity because it is associated with the force and force is a vector quantity. Which of the following is a scalar quantity? 80 meter cube, 5 newtons, 7 meter per second and 55 meter per second square. So 80 meter cube is the scalar quantity. So this is all about the vector and the coordinate system. Now in the next class we are going to start with new topic in continuation to the vector analysis and Cartesian coordinate system. So thank you all. Thank you all for the today's class. Have a nice day. Thank you.